Everyone, Dr. R here, going over an epidemiology question. So let's take a look at this question lead-in. First off, why don't you read through the question, hopefully starting with the question lead-in, then looking at the question answer choices, and then going back to the question stem, and then try to answer the question yourself. So push pause and answer the question, and then write here why the question is correct or incorrect. All right, so coming back to the question, considering the diversity and specific subpopulations, so that's interesting. There's going to be subpopulations within the patient base, which is the entire cohort. Which of the following is the primary advantage of employing probabilistic sampling? So probabilistic sampling is important. Methods in the study to achieve meaningful and generalizable. So meaningful and generalizable. So what does generalizable mean? So generalizable means that we are able to talk about it amongst other populations. So instead of us, so say if we had a population and then we took a sample, we want to make sure that this sample is generalizable back to the entire population. Or if this is population is maybe everybody at a specific medical school, what if there are other medical schools? We are hoping that our sample will not only represent this population, but will also represent these other populations. So generalizable to the entire population of people at medical schools, those kinds of things. All right. So generalizable insights regarding the prevalence of depression among described patient groups. So that's a pretty long lead-in, so I think this is going to be a complex question. This is probably a second or third order question, which will give you a lot more practice on how to dissect questions. All right, so now let's look at the answer choices. Allows for greater control over the sample selection process. So remember, we're talking about probabilistic, and what does probabilistic mean? It really just means a form of randomization, right? Which means the probabilistic piece means that there is chance involved. So whether somebody gets selected from a population to a group, right? So let's say there's group 1, group 2, this could be the experimental, this could be the control, and whether the population, a member in the population, gets selected into this is through chance. So that's why it's called probabilistic. That is, what is the probability or the chance that somebody is going to get selected into this group or this group, right? And so probabilistic has several different kinds of designs. So there is the simple probabilistic, right? So this is just the random sampling, which means that each person has an equal chance, right? So if I just did simple probabilistic, then, or simple random probabilistic, depends on how you want to call it, then you have a 50% chance of being in group 1 or group 2. There are other types. There is a stratified, and so stratified has less than 50% or less than equal chance, or less than equal probability of becoming. And the reason why is because we now have, what if we had in our population and in our groups, we wanted to look at age. So we had age groups. And so if our age groups were designed in a way where we had below 30, and then from 30 to 60, and then above 60, so then we would have 3 different groups that we would want to put them into. And so this is called stratifying. We are stratifying by age group. This could also be ethnicity, this could be weight, this could be height, it could be a number of different factors. But that's what stratified means. Stratified means you're putting in things into different buckets. And so you can see here that there is no longer a 50% chance of this population going into a group because there's 3 groups. There is less than 50% chance of going into those groups. And then there is a cluster sampling. So the cluster sampling can be around specific groups or specific clusters within the population. So it could be something like location. So we might do something by zip code. Or we might be doing something by a genetic identifier. So maybe a specific gene or something like that. There can be all different kinds of things that we cluster them, which is a type of stratified, but it's different because we're looking at groups and clusters of patients within the population. So you can imagine now, this is also a less than equal chance of getting into these groups because we're clustering them into different groups. So when we're talking about probabilistic, there are 3 kinds. Not all of them are equal. Some are less than equal, and some are equal. So we need to consider that. So does it allow for greater control? Does probabilistic allow for greater control? That's questionable. So what do they mean by greater control? If it is by chance, that actually removes control, right? So me as a researcher, I have less control over who in this population goes into this group and goes into this group because that is happening by chance. I'm not choosing, oh, well, I want this person in this group and I want this person in this group. So to me, this one is questionable. It doesn't seem to fit. So that ensures that every member of the population has an equal chance of being selected. Well, we just talked about that right here. So depending on which kind they're talking about, simple, stratified, or cluster, that is not true. Only in simple are we talking about an equal chance. So we have to go back up here and see if they're talking about simple. If they're talking about cluster or stratified, then this is not true. Also, if they're talking about probabilistic in a general sense, then that's not true either because they're not all equal chance, right? Some are less than equal and some are equal. All right. Ensures that the sample is representative of the population of interest. So when we do this selection by chance, then the opportunity for us to choose groups that is balanced increases because we are selecting by chance to create these groups. We're not selecting because they are convenient. Our sampling is not convenience, like they all show up or they all have the same characteristic or they all have the certain time off so they can be chosen. We are actually looking at chance. So this is actually a good answer option, so I'm going to mark that one down. I like that one. Is less expensive than non-probabilistic? That's questionable. I guess in some situations, doing a random sampling like this by chance could be less expensive, but doing a non-probabilistic, so non-probabilistic might be doing like a convenience sampling, or just choosing everybody in the population and having them self-select, right? And so if they self-select, so for instance, let's just take all of the population in Boston, right? And then what we're going to do is we want to look at smoking and lung cancer. They're going to self-select. S-E-L-E-C-T, my apologies. They're going to self-select because we can't force somebody to go into the experimental group as a smoker, right? So that is an issue. If they are a smoker, then they become experimental. If they are a non-smoker, then they become the control. The problem is that if they are a smoker, they might have other characteristics that impact what is happening here, which makes this less representative of what's happening in this population. Or if we looked at New York and LA and New Orleans, these characteristics in smokers from Boston might be different than New York, LA, or New Orleans. Same with the non-smokers. So it makes it less representative, less generalizable to other populations if they do a self-selection. If we randomize and there's a chance of selecting, we might have more balanced groups. All right. So as far as less expensive, I don't know, but those are non-probabilistic, right? Convenient sampling, self-selection. Is less time-consuming? I don't know. I mean, it might be true that it's less time-consuming, but that might not be completely true at all times. So these two are questionable to me because I don't know if they are always this. So I'm throwing up some flags there. All right. A researcher is conducting a study in a large, diverse hospital to explore the prevalence. So we're looking at prevalence. And you remember that prevalence, right? We'll go back to my chart here. Prevalence is the total number that have the disease in a population at a specific time over the total number in the population at that same specific time. Let's contrast that. So that is all cases. Let's contrast that with incidence. The number who develop the disease, that is new cases at a specific point of time or period of time, and the number who are at risk of getting this disease during that same time period. So that's the difference between incidence and prevalence. And so we are looking at prevalence in this situation of depression among adult patients with a history of heart disease. So they have heart disease, and we are looking at the prevalence of depression. The population of patients exhibit a wide range of demographics. Okay, so that is what this was talking about, subpopulations. So a wide range of demographics. Well, what does that mean? So demographics can be things like age, race, language, weight, height, right? These are all Table 1 characteristics in research studies. So we might want to see that there's a wide range of demographics and medical histories. So they might have multiple different kinds of cardiovascular disease or heart disease like congestive heart failure, or they might have had an MI, those kinds of things. So this is where they're getting at with subpopulations, and there's a lot of grouping, which sounds like to me they might be doing some stratifying. Remember down here we talked about stratifying, which we might have people in different age groups, or we might have people in different ethnicities or races, or different medical histories. All right. So including varying degrees and types of heart disease. That's what I was just talking about. So given the variability and specific subgroups of interest, those who have experienced a heart attack and those with other forms of heart disease. So their subgroups are heart disease, MI, and heart disease. So those two are ones they're interested in. But they also might be interested in age and race or ethnicity or language or weight or height, BMI, those kinds of things. The researcher aims to ensure that the study findings are generalizable. So they want to make sure that this is generalizable to the entire population of the heart disease patients in the hospital. So in the hospital is the population. And they want to make sure that these groups are generalizable. So how do we do that? So the primary advantage of probabilistic sampling Does it allow for greater control? Well, not really, because it's driven by chance. And chance is not, or greater control is not going to impact, or it might even negatively impact generalizability of our groups to our population. Remember, I said self-selection, we might have greater impact or greater control over the sample selection process because we chose all of Boston. We could have chosen New York, LA, New Orleans, we could have chosen all of that. So I have much greater control, and I chose smokers versus non-smokers, so they self-select, but I had, as a researcher, control over who goes into this. Convenient sampling, I have a lot of control over because I can say who is included and who is excluded. All right, so I'm going to say that one is not most likely correct. Ensures that every member of the population has equal chance of being selected. Well, this is actually true if we were talking about simple probabilistic. Remember? Simple probabilistic. That is this one where we have a population, we go into two different groups. In this situation, it does impact generalizability, but I got the sense that we're really talking about a stratified sampling here. So I still am questionable about this. Now let's go on to the next one. Ensure that the sample is representative of the population of interest. In this situation, given all this information and what we're trying to do is generalize, I believe that the primary advantage in this situation for probabilistic sampling is that it ensures that sample is representative of the population. So I am highly liking this question or answer choice. So I'm hoping you are too. But let's go down here and think about these two. Less expensive, we talked about that. Not always in some cases. So that one is less likely than this, and even less likely than B, as well as this one. This one is time consuming. It's less likely than C and even less likely than B. So let's contrast these two. So B and C. Yes, it ensures every member of the population has an equal chance if we're talking about this, but because we're talking about probabilistic sampling in a general sense, then it would also consider stratified and cluster sampling. So I think this is less likely of the correct answer, and C is the most likely correct answer. I hope you agree.